In this problem, we're given an arrangement with two isosceles triangles that are intertwined in a very interesting way. Those triangles are ABC and BDA. And you will see in just a moment why I said the letters in that order. Now, in the first variation of this problem, we're given the lengths of AB and BD, and we're asked for the length of AC. But other good variations are possible. For example, we could be given the lengths of AC and AB, and asked for the length of BD. Or we could be given the lengths of AC and BD, and asked for the length of AB. In other words, we could be given the lengths of 2 out of the 3 segments, and asked for the length of the third one. And all of these variations are very interesting, and all of them can be solved in the exact same way, by observing that the two triangles are similar. In other words, they have the same shape, but different sizes. Now let me first convince you that they're indeed similar, and then we'll talk about how to take advantage of this similarity. To conclude that these triangles are similar, we have to pay attention to the angles. First of all, they have this angle in common. Next, because the triangle ABC is isosceles, this angle at the base is the same. Now, because the triangle BDA is isosceles as well, the other angle at its base is the same as well. So, these isosceles triangles have the same angle at the base, and that's enough to conclude that they are similar. Actually, there's a rule that says that if two triangles have identical angles at corresponding sides, then they're similar. But if I were you, I wouldn't worry too much about those rules and rely on my intuition. What makes this situation just a little bit confusing is that the larger triangle is upright, while the smaller triangle is on its side. So you should use your powers of imagination to imagine the smaller triangle in the upright position as well. And then you will see very clearly that the two triangles are similar. So let's agree that we have established their similarity. How does it help us? Well, let me illustrate with an example. These adjustable wrenches are different sizes, but the exact same shape. So geometrically speaking, they are similar, which means that all of their dimensions are proportional. Let's say that this wrench is twice as long as this one. Then it is twice as wide as this one, and twice as thick as this one. Also, the diameter of this circle is twice the diameter of this circle, and so on. Also, and this is important, the proportions within each wrench are identical. For example, the ratio of the thickness to the width is the same for both wrenches. And the ratio of how far the wrench opens to its length, which is very important if you think about torques, is also identical for both wrenches. And we can apply the exact same ideas to our triangles. So let's do that. So, our triangles ABC and BDA are similar, just like our wrenches. And you can now see why I named the letters BDA in that order, because it's the consistent order. When I say ABC for the large triangle, I'm naming the base first and then the remaining vertex. So for the smaller triangle, I want to do the same. I want to name the base first and then the remaining vertex. So that's what I do when I say BDA, the base first and then the remaining vertex. So they're similar, which means that the corresponding proportions within each triangle are the same. In particular, the ratio of the long side to the base is the same in both triangles and must be 6/4, or 3/2, because that's what it is in the small triangle. So the ratio of AC to AB is 3/2, and 6 times 3/2 is 9. So AC is 9. And this variation of the problem is solved. To solve the other variations, where you're given AC and AB and you're asked for BD, or you're given AC and BD and you're asked for AB, can be solved similarly by taking advantage of the same relationship, that AC over AB equals AB over BD. So what you need to do in those situations is plug in the lengths of the known segments into this identity, and that will yield a very simple equation for the unknown length. Hey, thanks for watching. Click on this logo to check out our complete SAT math platform. And if you know someone studying for the SATs, please let them know about it. Thank you. Hey, got it on the very first try.